Right here I've got an opened up VHT Special 1220 RT combo amp. And the reason I have it opened up here is because it wasn't making any sound. So it got brought over to me, and I got it over here and quickly noticed that this fuse right here was blown out. And I checked the power tubes, and as you can see there's a lot of shaking around inside of there. My guess is, or my initial guess was that one of these power tubes had arced over, the two things contacted each other, and if you're lucky it's as simple as replacing a fuse, but unfortunately it wasn't. I replaced the fuse and tried a different set of tubes, which are in there right now, which I can't really show very well because it's dark in there, and even still there was just no sound coming out of it. So my first concern was that it had blown out the output transformer, but I checked across that and the output was fine, and right up here we were getting power, which indicates that the power transformer is fine. So then it was time to dig into the circuit a little bit. So this one here has one of those power scaling circuits. This thing that says watts right here, that's not just a stylized way of saying the master volume. This actually is a watts knob. It has one of those London power scaling circuits. And if you look at it in the schematic, it comes right after the caps for the power right here, the first power section capacitors, and then it runs over to the power scaling, which is over here. And the power scaling on this amp is actually slightly different from the way it's shown in the schematic. Rather than just coming straight from these, there are these two resistors right there, which are, I'm going to say, 150 ohms a piece. I'm guessing this is some sort of a protection in case of a tube arc over. But these two were both burned out, and so I figured, well, maybe I'll be lucky and I'll just jump over these, replace the resistors essentially in time, but jump over them. And the way I was testing jumping over them is with this light bulb in the way. The light bulbs work great for circuits like this because if they light up, there's a problem. There shouldn't be enough current through like a high voltage circuit like this to light up a light bulb. So when I was running it, it ran sort of for a bit, and then the light bulb would intermittently flash on and off. And so what I think has to be going on in here is that if you can see, and this is going to be very difficult to show on the camera here, but if you take a look down in there, this is where the actual MOSFET is, right there, and I can show where that is in the schematic, and that right there is what actually scales the power. Like there's the potentiometer over here goes to one of the pins on there, and then the circuit runs across it. But there shouldn't be any way for that to actually short out, because if you look in the schematic, there's no connection between there and ground for it to short directly to. So I have to imagine that there's actually just a straight short. Maybe it got too hot or something and melted like an insulator up here on top, or maybe it just punched through the mica insulator. So my guess is that there's just like an insulator, an electrical insulator, that will also transfer heat, because you can't just take this off the board entirely or it'll overheat, because there's a lot of heat that gets dropped through there. I think there's quite a few. It's, in theory, this thing can drop up to 90 watts provided it can get rid of the power, get rid of the heat from it. So that's why it's connected to the chassis. So you can't simply just lift it off and then see if that clears up the short. So I'm thinking there's probably some sort of like a washer in the way, like a plastic one right there, that is that has melted and shorted through, or it's just punched through the mica spacer. So in order to test it, what I'm going to do, because I noticed in this circuit here, there's one other thing that's not shown on the schematic. There's a diode, I believe it's this one over here. Yeah, there's a diode between that circuit, I think a protection from backflow between there and the rest. So I should be able to run that light bulb in between just to test out. And if this theory is right, then when I'm running the light bulb between the back of here, the inputs to these resistors, and then past the diode over there, which it can't short back across, the amp should work fine, except the watts knob won't work. Here you can see how I have the light bulb down here connected across the blown out part of the circuit to skip over the power scaling. This, where it's attached on this side, this alligator clip is connected to where the full power supply power connects to before it goes into the power scaler. Then it runs through this light bulb to limit it and make sure nothing happens. And on this side, it's going into where it hooks up to the output transformer on the filtering resistors on that side. So basically everything's as usual except the power scaling circuit is taken out. And now if I plug a guitar in, I get sound. Of course the watts knob up here doesn't actually do anything because I've bypassed that circuit entirely. But that does show that the rest of the amp working fine because we got power, everything's working, and the light bulb isn't lighting up, indicating that there's too much current drawing through. So now we have to figure out where the short is on the power scaling circuit. One thing that I should have noticed, I took this top board off here when I was trying to get this alligator clip in there because I couldn't get it in otherwise to where I needed it to go, but I had to put this screw back in here because this screw runs down to ground, and this is important for the bias supply. Without that screw in, the amp won't bias correctly. I don't know why they ran an important ground like for a bias through just a screw there, but anyway, the amp runs fine without that there. Without it, the bias is way off and it won't sound good at all. And now you can see that I've loosened up these boards, and now I was able to get under here in the MOSFET. Actually smells quite burnt now that I'm in here. That's where the MOSFET was hooked up right there, connected down to there, using this whole chassis as a heatsink. But there's some insulators, which I pulled out, and they're up here. So there's this insulating pad that goes underneath, which is a silicone insulator. I was thinking it was mica, but I guess it's silicone on this one. And that sits between the MOSFET and the board itself, which conducts heat but not electricity. And then there's this plastic thing on top that goes between this screw. And what happened at some point, it got too hot, I'm guessing when a tube burned out, and it managed to scorch and punch right through this plastic here and then start to arc over. It's going to be difficult for you to see, but that scorch mark on the tube there, or sorry, on the screw there, that's where it was arcing right over from there, and it actually punched a hole through the spacer on this, and it's all charred and it smells really burnt in there. So that was the problem. It just kind of was the electricity just punched right through there and was jumping straight from the screw there and shorting everything straight out to the chassis. And when I was running through the light bulb, everything was working except for when it shorted out. So I'm pretty sure this MOSFET should be fine. It was bringing down the voltage and everything it's supposed to. It might not have been for much longer, but at least for the moment, this is still working. So all I really need to do is replace these insulating pads over here and put that back together, and also replace those two resistors in the back, which are burned out, and then replace the fuse with the right one, because I don't have the right one in there right now. And then that should be it. Everything in here should work once I've replaced those and put it all back together. I got my parts in today, and here's what I have. I have a fuse, first of all, to replace the one that's burned out. I got two resistors to replace the ones that are likewise burned out. And then I got this here, which is an entire kit for replacing the insulator in the amp here. And this one is mica, unlike the other one, which was silicone. So in order to put this one in, I have to use a thermal compound because it doesn't kind of hug the metal the same way the silicone spacer would. I believe mica ones actually work slightly better, but they require the thermal paste. You can't just put them in by themselves. It's important to use a non-conductive thermal paste, just in case a little bit spills over, since we're dealing with some pretty high voltages. Something too close could cause an arc in there. So I'm just going to go put all these things in and then give the amp a try. Alright, now I've got the MOSFET back in place there. You can see that I've put thermal paste on both sides of the mica, both between the mica and the MOSFET, and between the mica and the chassis that it uses to cool off. And then I put in the resistors back over here, and also put this red wire back into place, which I believe goes to the preamp or something off of there before the power scaler. So make sure that's connected up again. And in order to get at it, I had to desolder this wire and this wire from the top over there. And that seemed to be all I really had to do to get at it. So now it's just a matter of putting this whole thing back together and trying it. Now that I've got all these boards back in place and put in the ground screws, at least, to make sure that everything's grounded out in the bias supply, what I can do is test the voltages here. So by putting one lead of the multimeter just in the chassis somewhere to ground, and then putting one on the capacitors that lead to the power amp section, now you can see that I'm getting about 78 volts there, and that varies as I move the watts knob up and down, all the way up to the full voltage. And this one goes up to, I guess that's 318 right now, because right now it's in the low power mode for 6v6s. It would be closer to 500, I believe, if I had it set up for 6 L6s and EL34s. So it looks like everything's working. The only thing to do now is to put this back together entirely and plug the guitar in and try it out. Alright, now I've got the whole thing back together, and I put a new set of power tubes in there, since I'm suspecting the original ones may have contributed to the problem with the amp in the first place. And aside from the fact that I'm out of tune, everything's working as it should. The watts knob here does what it's supposed to do, and I was looking into it. It makes good sense that there was no damage to the MOSFET itself, because I was looking up the diagram for the MOSFET and what the connections all do, and the shell, which would have shorted out to the chassis, is connected to the drain, which is what's connected to the actual source of power over there. So when it shorted, it was shorting directly from the input rather than shorting after the MOSFET, which would increase the chances of damaging the MOSFET in the process. So it was just fine. It just needed to be isolated again so the amp could work. So if you're having this problem with an amp like this, or any amp that has one of these, I think it's called the London power type of power scaling circuit, there's a good chance that that's the problem there. And I've actually seen accounts on the internet of this problem showing up before in amps and never found a solution. I think some people just kind of assumed the amp was gone. So that's a good place to look if you're having this sort of a problem that's blowing out fuses and burning out resistors in the power scaling circuit. So there we go. That's all set. Thanks for watching.